If you were to take anything that took up space, including gas, put it under a microscope, and then zoomed in as much as you can, this is what you'd see. Now, to give you a sense of how small the atom really is, let's say you had a newly sharpened pencil. If you zoomed in at the tip of that pencil and then counted each individual atom, you would have a quadrillion atoms. So, it's really, really small. Now, the atom is composed of three subatomic particles. Subatomic just means smaller than the atom or within the atom. The proton, the neutron, and the electron. The proton and the neutron are inside this thing, a shell at the center of the atom called the nucleus. And the nucleus is just a term that refers to the shell that contains both the proton and the neutron. So when people talk about the nucleus, they're just talking about both the proton and the neutron. Outside the nucleus, we have the electron cloud or the electron shell, and this is the region of space that the electron takes to move around the nucleus. And instead of it actually following a perfect elliptical path like I illustrated here, it actually just goes in whatever way it wants to. I just drew the elliptical path because I think it looks cool and people like doing it. So now let's talk about the properties of each particle. The proton is a positively charged particle with a value of +1. The neutron is uncharged and the electron is a negatively charged particle with a value of -1. So this actually explains why the electron doesn't just fly into space and instead follows a path around the nucleus. Well, it doesn't follow a path, but it stays near the nucleus. It's because the proton and the electron have opposite charges and opposites attract. But why doesn't the electron ever just crash into the nucleus if they're so attracted? Well, the reason for that is because the electron is so fast that it just goes anywhere but the nucleus. Like, it doesn't hit it at all. But you're probably wondering, then why doesn't the proton just get out of the nucleus and then hit the electron if it's also attracted to it? Well, the bind that keeps the proton and the neutron together is so much stronger than the attraction that the proton and the electron feel. And this force is called nuclear force. And I'm not going to talk about it more. I just said it. It's not really that important right now. I just said it so you to keep you from overthinking. Okay. Now let's talk about what each particle entails. The proton determines the atomic number of an atom, and the atomic number determines what kind of element the atom is. So this atom has 2 protons, that's a helium atom. If we increased or decreased the number by any amount, we would have a completely different atom with a different element. Let's say I added 2 more protons here. That would be a carbon atom. If I reduced it by 1, that would be a hydrogen atom. The neutron contributes to the mass of the overall atom. So that's the atomic mass of the atom, and you calculate it by adding both the number of protons and neutrons. So the atomic mass of this would be 4. Now the electron determines the energy level of the atom, and the energy level determines whether the atom will take an electron from another atom, give an electron to another atom, or share an electron with another atom. Because that's how that's how atoms bond with other atoms. We'll discuss more of that in another video if I feel like it. Okay, goodbye.